Welcome to another episode of SaltAir. My name is Tom Hatch. I'm the creator of Salt and the CTO of SaltStack. One of the most common things that we get asked is, what's the difference between grains and pillars? This is a pretty fundamental component of Salt, and it's used to expose a pretty vast amount of functionality. So understanding the difference between grains and pillar can be really important to getting the most out of your usage of Salt. Grains and pillar can be described in a really simple way. Grains are information about a minion generated on a minion. Pillar is information about a minion generated on a master. Now, that's pretty simple and straightforward, but it starts to really define where grains and pillar come from. So, if we're generating the information about a minion on a minion, then what we're going to be generating about that minion is going to be pretty close to home. And that's why grains contains the operating system. It contains the version of Python that you're running under, and contains information about that system. Whereas pillar turns into a variable cache, someplace where it's easy for you to put variables that need to be assigned to systems. By default, grains is populated. When you turn on a system for the first time, it finds out what OS it is. It finds out network information. And you've got a pre-populated set of wonderful little tidbits about that system. When you start up the pillar, it's empty. Everything inside of the pillar is there as a slate for you to add to it. Subsequently, when we look at SaltStack Enterprise, we use the pillar as a medium to distribute extra data down to the minions, to do specific operations or to fulfill certain applications of the utilization of SaltStack Enterprise in your infrastructure. And so as we pull away, the next thing I want to talk about with grains is that since grains has information about that operating system, they are critical to setting up the minion so that they set up the use of states, that they set up beacons, and they set up the execution modules. Because these grains are able to come back and say, you're running on Red Hat, that's what tells the execution modules to load up Yum as the package manager. You're running on Fedora, let's load up DNF as the package manager. Windows, we're going to load up Salt's Windows installer tools. Subsequently, since the state system is built on top of those execution modules, that's why when we run package.installed, we don't have to tell it whether or not we're going to use Yum or Pacman or apt-get. Salt already knows. And similarly with the beacons know what underlying libraries they need to use to fulfill whatever event tracking they're trying to do. Also, the beacons become the backbone of being able to view what assets you have, being able to sort and target and interface with these systems. So when the beacon information floats all the way up to SaltStack Enterprise dashboards, you're able to get that large-scale asset view of your infrastructure. Now, the pillar. The thing about the pillar is that since it's generated on the master, it gives you a lot of diversity as to how you can populate that system. The pillar itself is retrieved from the master, and then it's held in memory on the minion. And so it is noteworthy that if you make a pillar that's a gigabyte big, that might be a memory constraint issue. We've very rarely run into such problems, though. Usually people's pillars are pretty direct and to the point. But the pillar system can allow you to tie into external systems to gather variables on a per minion basis. So if there are external asset systems or there are external configurations and configuration databases, the pillar can use its external pillar system to reach out to those systems and grab that information. Pillar is also a very good means to distribute security information. Things like keys and certificates. Something that you want to say that only a certain minion can have access to this information inside of a pillar. And so it's very common for a pillar to connect to systems where you have the encrypted storage of these resources, so that it's easy for a master to connect in, grab that information, and then distribute it properly down to specific systems, making it easy for systems such as certificate deployment. One of the other things I want to talk about with these systems is tying back into that key management infrastructure. One of the common use cases that we have is just managing something as simple as SSH key access. It's easy to be able to say, using things like grains and pillar, that I want to make sure that certain people have SSH access to certain systems based on those systems' roles, based on what those systems are being used for, or perhaps where they're physically located. It makes it easy to then use things like Salt's built-in SSH management libraries to be able to specify that I only want to have certain people gaining access to this system. But also it makes it easy to clean those things out. There are a number of situations and infrastructures where too many people are left with access to systems. And it's all too common to go into infrastructures, and even though I think that we all know it's not a good practice, those practices still happen. We wouldn't have to flag a practice as bad if it never happened. And so it's very common to go into infrastructures and see that too many people often have access to systems when they really shouldn't, or people that haven't worked at a company for a long time still have access to systems. Being able to combine Salt's controls, where one is able to store things like public SSH keys in a pillar, and then use that pillar to target and deploy specific keys to specific minions, is one of those use cases around securing an infrastructure that Salt has long been in use for. Thank you again for watching another episode of SaltAir. We're excited to have you, and we're excited to continue to show you some of the great aspects of Salt and the systems that we've worked so hard to deliver into the world. Thanks again. Bye.